All right, should we get started?
Sure, sure.
All right, my name is Derek Ashmore. We're talking about microservices, more specifically microservices written in Java. Basically, let's start out with a question. By show of hands, who has read at least one article or seen a presentation on microservices? Okay, it looks like about 30%. If you didn't raise your hand, don't worry about it. I'm going to cover some definitional stuff so we're on the same page. All right. I'm a professional geek. I started as a programmer in 1987, which puts me at old but not quite ancient. I've had a variety of roles. I've been basically doing Java since 1999. In addition to being a developer and architect in a past life, I've been project manager, database administrator for both Oracle and DB2, Linux system administrator, and a variety of other roles. Translation, as I like to move around a lot. And I'm one of those weird people who spend the wee hours of the morning writing books and open source software. Let's talk about presentation resources. I go to conferences and I see people like feverishly trying to take down URLs and that kind of stuff. You don't need to do that here. This slide deck is on SlideShare. If you Google Derek Ashmore SlideShare, it will come up. All these links are active. All right. With SlideShare has this weird feature built into their product. Everything from the fourth slide on will honor hyperlinks. This is slide 3, so I had to spell URLs out. So don't get fazed by that. All the sample code that I point to in this presentation is on my GitHub. This presentation is more geared toward architects, but a lot of people like to get their hands dirty into code. So there is a sample microservice out there written in Java that illustrates many of the points that we're going to talk about today. And before we move on, I like to run informal presentations, so feel free to shout out questions if you have them as we go along. Okay. As far as the agenda, basically right up front, we're going to do some definitional stuff. I'm going to tell you what microservice architectures are, what benefits they provide, why you might use them. Give you a glimpse into what are the ramifications, because the world is a little bit different in a microservice architecture than it is in a traditional web app. We're going to move on to design considerations and patterns. Yes, we have coding patterns in the microservice world too, like we have coding patterns everywhere else. And we're going to see the world changes a little bit, so I'm going to concentrate on design considerations that are specific to microservice architectures. Some of the design considerations are the same that you're familiar with, and it's not that those aren't important, it's just I'm not going to focus on them here. Packaging options. Ears and wars are so passé. It's just so 2000s. We've moved on. Microservices does other things, and we're going to go over the more popular packaging options. And then every new technology paradigm comes with marketing fluff, or more specifically, benefits that you're supposed to get, but if you look behind the curtain, there are fine print items that you have to satisfy in order to get those benefits. I'm going to try to separate the wheat from the chaff for you a little bit and point out where those are, and we're going to do some summary and Q&A. Okay? Microservices. I'm going to start off by irritating every geek in the room. Geeks like concrete definitions. All right? Microservices doesn't have one. All right? Think of microservices as a set of common traits that most, if not all, microservices have. They have a single functional purpose. By functional, I mean business. They have a single business purpose. They do one thing well, they only do that one thing. And if the business regarding that one thing changes, usually it's only that service that needs to change. Okay? It's not dependent on execution context. That means the service doesn't care whether it's executed as a part of a batch stream, if some user indirectly kicked it off through some web app application somewhere, or in what context. It doesn't care. As long as it has its inputs, and as long as it has its resources, it works. It runs as an independent process JVM. That is, in the old days, to save on licensing, we would stuff multiple applications into the same container to conserve, save licensing bucks or what have you. Microservices don't do that. They run independently. They use a standard interface, which is usually REST web service, but SOAP isn't uncommon. And what's really important is the standard interface. When other people give microservices talks, one of the examples they like to use is Linux. If you're familiar with Linux and all the little discrete little commands that you can do an ls, pipe into a grep, pipe into a cat, and you can just keep stringing those on forever. Now, Linux uses standard input and standard output for a standard interface, but it's basically the same thing. I prefer another analogy. I think it's simpler. Your stereo system. Yes, that's hardware, not software, but it illustrates the point. 2 years ago, when I replaced my speakers, none of the other components in my stereo system cared. They were oblivious to the change. It didn't matter. 4 years ago, when I replaced my receiver, same thing. 5 years ago, or last year, when I added a Roku device, doesn't matter. All right. Microservices does for software what stereo system components do. Let's contrast this with what we're used to. Traditional web application architecture. Is anyone else hot in here? Okay. With a traditional web app architecture, you usually have something that deals with the user interface. You have some logic in between there. You usually have some sort of a data access object layer, and then you have an application database or databases sometimes. They're highly cohesive. Yes, you may separate that into layers, but that whole set is meant to be deployed as one unit. There's a word here. It's an interdependent set. It's meant to go together, and basically it scales as one unit. If you have an application that, say, has functionality for users and then an admin screen that only a couple people use, well, as you scale up the application, you scale up the admin page as well. You don't really have a lot of flexibility in how you scale. And it also starts to break after the code gets so large, right? Has anybody had the displeasure of working on an app that is so large that you can't really maintain it very well? I see a couple of hands. I'm not alone. I feel better now. When it gets to that point, we term it a monolith. All right? Typically, monoliths have very long QA test cycles because it takes so long to regression test them. And you run into the unintended consequence problem. That is, even if you've got a good test harness, you tend to get situations where you go fix one bug, and because of the complexity of the app, you accidentally create two others. And it's like playing a game of whack-a-mole, all right? That's one of the characteristics. It becomes hard to burn in new developers, right? Because there's just so much to know about the application. You start getting married to your technical stack. Upgrading Hibernate from version 3 to version 4 becomes a bigger deal because of all the regression testing involved, right? Much less if you want to move out of Hibernate and into Abatis or one of the other ORMs. In essence, what really happens, whatever got chosen when the application was created, is basically what is chosen throughout its life. It's very hard to change. It also becomes harder to diagnose bottlenecks, particularly memory bottlenecks. If you've got a giant haystack of 500,000 lines of code, a couple of them have a memory leak, that's a lot harder to find than if you're diagnosing memory leaks in, say, a microservice that might have 2,000 or 4,000 lines of code. All right? Typically, people don't start out developing microservices. they take their monoliths and they refactor those gradually over time into applications that are less of a monolith and a collection of microservices that support it. So I'm gonna peel back the onion on a typical application. The presentation layer. There are good business benefits to have a cohesive user interface. And so that's very hard to break up. If web frameworks are very notorious for not playing well together. And I'll give you an example. Java Server Faces and Spring MVC. Both very good platforms, all right? Both very robust. If you try to use them in the same application, you'll quickly find that you're kind of swimming upstream, all right? So that's just exempt the user interface right now. We'll talk more about that later in the program. Typically, you'll start out with what's below the user interface and you'll separate that into well-defined microservices. And typically when you start this process, you'll still be using the same application database, but that's a problem. The whole idea of microservice architectures is to reduce coupling, right? That database is coupling. If I go change that data structure and I've got 12 microservices reading that same database, I potentially have to deploy all 12 microservices at the same time. And that kind of goes against the grain. The idea is a change happens and only one or at the most two microservices get changed. So consequently, in a microservice world, in an ideal world, what you want to do is you want to break it up so that each microservice has its own database. All right? But that gives us a problem, and you've probably already thought about it. Most organizations have data that's common throughout the organization. And I'll give you an example. I spent several years in a higher ed market, so I intrinsically think about that. Campuses. Indiana University has a Bloomington campus, has an Indianapolis campus, has a South Bend campus. They've got campuses all over the state. Every service on the planet in a higher ed application would need to know what campus it's concerned with. So what do you do with that common data? You've got two choices. Basically, you can wrap a service around that common data, maybe make a service who is the system of record for all campuses, and every service that needs to know about a campus will call that service to get its information, or you make arrangements, and I can't believe I'm saying this as a former DBA, you make arrangements to copy that data for every service that needs it. Between the two, I prefer the service call method, and you're going to think, well, gee, isn't that a performance hit? And the answer is yes, it can be, but there are ways to mitigate that, which we're going to talk about. One of the benefits, a lot less technical lock-in. We talked about upgrading. Actually, let's take an example. Who has attempted to upgrade or get their organization to upgrade to JDK from version 6 to version 7, or from version 7 to version 8, and discovered that it takes an act of God to do that? Right? We've all seen that. In a microservice world, basically, you can upgrade the JDK for an individual service without affecting any of the other services. So it's a much smaller job. And you can say the same thing for any other part of the tech stack upgrade that you care to make. The other thing is you're not married to the language you write services in. I don't know why, but if you wanted to write a microservice in PHP, you could do it. If you wanted to use Go or Scala or C++, you could do it. And since each service has their own database, one service can use PostgreSQL, another service can use Cassandra or one of the other NoSQL databases. Suddenly you have a little bit more flexibility. Now with that comes a little danger. Organizations still have economies of scale, right? If you're hiring labor to support database platforms, it's a little bit easier to support 3 or 5 than it is to support 50, right? So just because this barrier goes away doesn't mean that you necessarily want 50 different database platforms or whatever it is. You still have to make intelligent choices. What it means is that one of the barriers to switching is no longer there. Easier management, higher development throughput. a lot of the time, as a project manager, you see this, a lot of the time that eats up development staff is coordination time, communication time. By separating things into small focused units of work, what happens is those teams are much smaller, and as long as you're good at contract management, they can work heads down coding. They burn less communication overhead. And what that means is generally they can produce things faster because they don't have to deal with bureaucracy. There's some fine print associated with this. You don't automatically get it. There's some things you have to observe, and we're going to talk about that later in the program. Now, about this time, people start thinking, well, gee, isn't this SOA? And the answer is yes, kind of, sort of. SOA has the same problem. It means different things to different people, okay? But there's one important difference. When I think SOA, I generally think of queues over God's green earth. I think of camel flows, mule flows, things that transform the format of messages as they go through the pipe to make sure that this service gets the data that it needs in its format, and that service gets the data that it needs in that other format. Microservices take a different approach. All pipes, all those transmission pipes in microservices are dumb. All right, think of the electricity supply for your stereo set. All right, it is publish and subscribe at its most complex. All the smarts are in the services. Okay? Design considerations and patterns. You're probably already thinking, well, gee, doesn't this create a whole host of problems? And yes, it does, but that's why we have patterns and design practices to try to mitigate those. I break this section into 4 different sections. One is writing service boundaries. It turns out that deciding a mission for a microservice is a lot harder, and people tend to screw that up, and that's disastrous if you do. So I'm going to spend some time on that. In this world, services that you call, because in this world you have services calling services, well, what if one of those services is down? We have to plan for failure a lot more than we do with traditional web applications. So we're going to talk about that. Data integrity. When a user does something in a traditional web app, we're all used to the safety of the transaction, right? An exception happens and a rollback gets issued. Your database is back in a consistent state, all right? In a world where that process may go through 5 or 6 different services, you don't have that safety. So the data integrity becomes a concern. And there's some design patterns that we can use to try to shore that up. We can go through that. And performance. Obviously, making a memory jump from one class to another class is a lot more performant than making a service call. Does that mean that microservice architectures have performance problems? Well, not necessarily, but it turns out that there are some things we can do to mitigate that as well. Okay? Service boundaries. I break things up into 2 big buckets. Core services, which are responsible for maintaining specific business data for a specific point in the business. They're usually named after nouns that are specific to the business. And you can usually express it as this service is a system of record for a fill in the blank. Be it a student, a course, a classroom, a campus, whatever. Typically those services do CRUD-like operations, and they do very little else most of the time. Process services, on the other hand, handle more complicated business processes, and they use core services as needed for their storage, but they basically separate out the complicated business process. I'm thinking of things like student debt collection, recording the student payment, that kind of stuff. Those kind of services will rely on core services. Now, one thing I can't do, and this will irritate geeks as well, I can't give you a magic heuristic that will give you a good service boundary all the time. It's partitioning or selecting what that service mission statement is going to be is an art. if you break up your business, your monolithic app into too few services, what you have is a few baby monoliths, right? You don't really get the benefit because those services don't have the single business focus that they're supposed to have. And if you break it up into too many, then you get excessive network hops, all right? So what good am I? If I can't give you a rule, I can give you a couple of sanity checks to help you recognize if perhaps you're working with a service boundary that's not ideal. And one is, for each service, you should be able to verbalize the mission in a single sentence using business terms. For the most part, we're defining a service. So the service verb, or the service noun, is in all these. But let's just skip the first two words. What is common about all of these? This service is a system of record for student information. This service registers students for classes. This service suspends students. What's common among all these examples?
Students.
I'm sorry?
Students.
I'm sorry?
Students.
Okay, you're right, okay. But what I was going after is they're all written in business terms. There is not, besides the word service, which we're defining, there is not a technical term in the bunch. If you want to create a service to maintain your Fed file, that doesn't really sound like a business focus to me. That sounds like some sort of technical concern. Probably not a good mission statement. Second sanity check. When somebody approaches you and they want to call your service, you get nervous. You start asking them questions like, okay, what are you calling before us? What are you calling after us? What exactly do you want in terms of its effect in some other business process? All those nervousness items are red flags that you're not context independent. That in fact, you really do care in what order you're being called, and that there's a wider context to understand. Your reaction really should be, here's the doc, let us know if you have any questions, goodbye. That's really what it should be. If you find yourself spending time analyzing a call flow, like, well, I need to call this service before I call that service, and I gotta make sure that this service is in such and such a condition, those are all red flags, all right? Chances are, without context independence, you're going to sacrifice some of the benefits of this architecture. Like many technologies, microservices has a very bad name. It begins with the word micro, which has everybody obsessed with size, okay? The reality is microservices are about having a single business purpose. It just so happens that if you do that, you end up with a smaller code base. In other words, the size part of it is a byproduct. It's not the end goal. Okay? And I'll give you an example. Take any service that you can imagine. You write it in Java, you're going to get a certain amount of lines. You write it in C, you're probably going to get a few more lines because that's more verbose platform generally. You write it in assembly language, not that you would do that, but you will get a boatload more lines. Right? Does that make it any less of a microservice? If it's well-defined, it's well-defined. The lines are going to vary depending upon the tech stack that you choose. I see some places will actually, when they do microservices, they'll actually put line limits on microservices to get into production. Insane idea, wild and crazy. Concentrate on the business focus. Because if you concentrate on line limits, you'll have people reducing, eliminating carriage returns and other shenanigans. In a microservice world, you basically need to design for failure, right? Yes, horizontal clustering or horizontal scaling and clustering is your first line of defense, but there are legitimate reasons for an entire cluster or an entire service to be down, right? If you're getting upgraded, resource it needs to function isn't available for some reason, that can happen. And in the microservice world, we're going to see that failing sooner is better. And we're going to go into that here in a little bit. And there are a couple of patterns I'm going to turn you on to mitigate some of these issues. reminds me of the definition of insanity, right? Because you literally are doing the same thing, and at some point expecting a different result. This pattern's very simple. It assumes that the target service is down temporarily, and that it will come up at some point. And so it takes a transaction, it keeps retrying it at usually a defined interval, and usually you give it a defined max number of retries. But the idea is that if the target service comes back up, the transaction completes, life goes on. It's best for asynchronous tasks. You don't want a browser waiting on something like this. And it only addresses temporary outages. There are tooling support. There is tooling support for it. I've got a sample retry pattern on my GitHub. CXF supports it. Spring Batch supports it with this retry template thing. HTTP client supports it. I imagine there's other support in other frameworks as well. Circuit breaker. Okay. This is modeled after the junction box in your basement. Something bad happens, circuit blows. Anything that's tied to that particular circuit doesn't have electricity. This software version works pretty much the same way. All right. Basically, if it notices a certain number of consecutive exceptions, it flips a switch, and the next time one of those types of transactions is tried, it airs out immediately. Now, why is that good? Who all has surfed to a web page with a browser, and the site's not up, and you wait for 60 seconds or 90 seconds, right? And eventually you get the message that says, hey, it's not up. The same thing happens in the web service world. So let's imagine this at high volume. Let's say I've got a service calling another service, and it's sized for somewhere between 10 and 15 concurrent transactions, right? But imagine that they're all waiting on some resource that they need. They're waiting this 60-second period, or waiting their 90-second period, or whatever it is. What will happen is that service will end up blowing up on memory, blowing up on max number of database connections in its pool, all sorts of other resources, and anything calling that service will then blow up, right? And that's the reason. It's an interesting twist on performance tuning. That's the reason why, if you're going to fail anyway, in other words, a service that you need isn't up, you want to fail out as quickly as possible. Because what will happen is, if everything's blowing up, finding the root cause becomes more problematic. Okay? Now, unlike the junction box in the basement, this circuit breaker will turn on again, and typically it's a configurable time period. So a couple of different configuration options you'll give these things is you'll basically configure the number of consecutive errors that it requires before it trips, and you'll configure some sort of time interval in which it'll let a transaction through and see if the target service is back up. There is product support for this buried in the Hystrix product. That is a large product set. I wouldn't add Hystrix to your stack just for the circuit breaker. I've got a sample circuit implementation on my GitHub, and I've got a link for more information on it as well. Dispatch via messaging. We do this in traditional web apps. Okay? The idea is, instead of calling a service to perform an instruction, we put that instruction on a persistent queue, and the service reads it off the queue and does it. The idea is, if the target service is down, the work just stacks up in the queue, and it comes back up, the work gets done. We've done this with traditional web apps. It's pretty standard. The tooling support for microservices is the same as what you're probably familiar with, but the JMS API and the Spring has some templates for producing. Design for performance. In this world, basically, with all the service calls going on, if the services, you make the services coarse grained just like you would for traditional services. And there are some patterns that we can use to eliminate the extra bandwidth needed and time needed for the network calls. So I'm going to take you through them. The first one is called backends for front ends. I've never quite seen it, but from published case studies, you pull up a page on Amazon, and the page comes up, and the rumors are that there are a few dozen microservices that get called to fill out the data on that page. I can guarantee you that when your browser pulls up the Amazon site, it's not, excluding the graphics and the GIFs and whatnot that the browser needs, to get the data, it's not making dozens of calls to individual microservices. You don't expose microservices directly to the World Wide Web because you don't control that network. All right? The idea is you'll make one or two calls to a server-side component for the presentation layer, and that server-side component will consolidate all the microservice calls that the application needs, that the browser needs, gather all the data. But all those microservice calls happen on your local network. Your network engineers can tune it, and it happens in an environment that you control. All right? Now, this pattern it's unfortunate, but this pattern is also known as the API gateway pattern. The API gateway pattern is different from API gateway products, which really are something different. So I usually don't use it, but I think we've covered all these other points. Expiring cache. It's not uncommon for organizations to have data that is more static. And I'll give you an example. Back to campuses for universities. It's not every day that Indiana University toasts the campus or establishes a new one, right? That data is very static. So the idea is we don't need to read it every time that we use it. The idea is to trade memory for speed. So we read it, we store it in cache, and then every call for that data gets it out of cache, not getting it directly from its core service or data store. And typically these caches will come with configurable options, how long to cache, when to expire the data. It's a continuum, right? Campus is an extreme example. It might be that student information, that's kind of static too, but a lot less static. So you might have a shorter expiration period on it, okay? So you get into design considerations there. There is tooling support for it. I personally recommend Google Guava. That's just my favorite. However, there are a lot of different products out there that do this. If you're an EH Cache fan, go for it. Anyway. Designing for integrity. We already talked about the fact that we don't have the safety of a database transaction. Right? So a rollback in a transaction that goes through half a dozen different services isn't possible. And two-phase commits really aren't viable in this world either, because you don't have one process governing the transaction. You really it's really hard to use that technology here. So we have a pattern to help mitigate that. It's called the custom rollback, and it's simple, and there's no product support for it. But essentially, let's take a hypothetical where we have a transaction that needs to issue multiple transactions. So it issues the first transaction, and that's successful. It issues the second transaction, and that fails. Instead of just failing, it basically issues transaction 3, which reverses transaction 1. All right? In other words, you're custom coding your rollback. Now, that's a lot of work. So you start making design decisions based on the probability of failure. All right? You've got two choices. You either code a custom rollback so that consistency is maintained automatically, or some support person has to go, in the event of a failure, has to go make the data consistent, right? Issuing SQL or whatever they have to do with the underlying data storage to make everything right. And you end up making decisions based on the expected frequency of error. The things that error out more frequently, you might code custom rollbacks for. The things that happen once in a blue moon, maybe you leave for manual intervention. All right, I think we've covered all of this. There's no product support for this because it's completely custom. All right, there's no way. Yes, sir.
In the previous one, what if transaction 3 fails? Right.
Good point. This pattern isn't foolproof. Transaction 3 can also fail. It's possible, although unlikely it's possible, that between the transaction 2 error and transaction 3, something takes out the initiating service, in which case there's nothing to invoke transaction 3. That can happen too, in which case you're in a manual recovery situation. The point is to try to reduce the amount of manual labor. All right? This isn't perfect, but it takes care of some percentage of it.
It seems like that violates your sentence design rule, and it seems like it violates your context design rule.
You gotta sort it out.
Well, except that the initiating service, by definition, needs to understand its dependent services, right? If you are going to process a student payment, you've got to you basically need to record something in the accounting system. You probably have to do something with that student status. There are probably 3 or 4 things that you have to do, right? Which means that you're going to be calling 3 or 4 services. The context is in the calling service, right? It is the self-contained unit of work that understands all those calls that need to be made to perform that business function. Now that's the context. You said it violated the other one?
The one sentence.
Oh, the one sentence. Not necessarily. It depends on how that service is defined. Suppose that service processes a course drop. Suppose that service processes a student payment. Suppose that service enrolls a student in a class. Those are concise business statements and business activities. Right? Okay, packaging options. For Java, we've got, since microservices run in a single process, typically what you'll do is you'll use something like a Spring Boot or a Spring or a Drop Wizard to basically wrap up your application in an embedded container so that you can, you've got basically one deployable. And then we get to Docker, which takes packaging up a level. And we're going to talk about those 3. There are more products that will publish Java applications as one jar, but Spring Boot and Drop Wizard are the 2 most popular, it seems. Basically what it gets it down to is the output is your jar, is your application. It also contains all the classes needed to run your application in a container. And Spring Boot uses either Jetty or Tomcat. I can tell you it's theoretically possible to use Spring Boot to deploy a non-Spring application, but you are definitely swimming upstream. All right, so probably if you're doing a Spring MVC app, you probably want to use Spring Boot. Required artifacts, you've got a couple of dependencies. You've got a plugin to actually do the packaging. And in addition to your application you deploy with Spring Boot, you've got a code and application class with a public static void main. That application class typically will have any configuration that your application needs in it. Spring Boot will take an application properties file that's application specific. Drop Wizard, on the other hand, does the same thing, but they add a nice little feature. They add a standardized YAML input, which can be used to define your connection pool sizes, define logging specs, define your port specifications, that kind of thing. And I like that quite a lot. Like Spring Boot, you have to define an application class with a public static void main in it. But typically in a Drop Wizard world, that application class is a little bit thinner because you have this configuration option through YAML that you don't necessarily have with Spring Boot. It uses Jetty. It doesn't allow Tomcat. It just uses Jetty, and it does provide metrics, diagnostics, and associated support options for free. And basically, like Spring Boot, from a main perspective, you need an additional dependency, and you also need an additional plugin. All right, nothing too intrusive. Then we get to Docker. Docker, you can look at it as a mini virtual machine. It has a container in it. If you look at Drop Wizard and Spring Boot, you're still dependent on a Java installation, right? You're still dependent on an operating system. In the Docker world, you put the Java installation in your Docker container, and you put your application in the Docker container, so it's all contained in one portable unit. And you give that unit to admins. Essentially, a Docker container has standard connections to the outside world. Within that container, you might deploy on port 8080. A system admin in the real world might say, you know, that doesn't work for me. I'm gonna deploy it on port 9999, whatever it is that they choose organization-wise. So inside the container, it knows the port is 1, and then Docker basically initiates the translation. And you do the same thing with disk. All right. Say your application needs to write or read from disk for something or other. Inside the container, you might know that as /data. Outside the container, it might be mapped to some place in your scene. All right. So essentially, what it does is it's truly packaged once, run anywhere, and it helps us a couple of ways. It's actually a standard format. We're seeing official distributions of Java in Docker, Tomcat, JBoss, many more. In other words, they already distribute their products in the Docker format, so you can just use it. Now you might be asking, why do I care about this artifact? As developers, why should I do ops work for them? All right? I think it's win-win. Yes, it's easier for ops. All software starts to look the same for them. All they care about is ports that get exposed, disks that needs to be mapped, and how much memory does the container need. That's all they need to care, and they don't have to care whether it's Java, whether it's Scala, whether it's Go, whether it's PHP. They're removed from that part of the process. Now that helps developers in a couple of ways. Communicating ops for new applications often takes a lot of time. This gets it down to a standard process, and it also gives you more freedom, right? Okay. I'm told that I've got short of time. It also gives you more freedom. Essentially what that means is if you want to upgrade your service from using JDK 7 to JDK 8, you can do it, right? Ops is only seeing the container. Yes, they can burrow into it and see it, but you can control that, right? You can make any operating system or JDK upgrades that you want, and there's a lot less hassle. And from a personal interest standpoint, every conference I go to, everything having to do with Docker has a line 3 miles long to get into it. So if you haven't checked it out, you probably should. All right, I'm going to breeze through the fine print. Marketing fluff. Is microservices easy to manage? It turns out that maybe yes, maybe no. It depends on how good you are at contract management. All right? You're basically relying on, in terms of ease of management, you're relying on those developer groups to be independent. And they can only, they can only do that if you give them good instructions about what their contract is and what they're to produce. Is it easier for developers to understand applications? I didn't mention this up front in the benefits, although it's frequently touted. And the reason is that I don't believe it. Yes, it's easier to understand a particular service because it's a smaller focus, it's a smaller code base, but to understand how services get put together to provide complete functionality, that's more complex, right? So that's part of the fluff. Increased development throughput. Well, maybe. You're getting that increased throughput through reducing the communication overhead. What that means is you only want developers working on one service at a time, and while it's easier to, well, actually, that's a bad point. You also have to be good with error detection, because if you're going to increase throughput, you're going to increase the speed at which things get to production, right? Which means sooner or later, because microservice architectures are harder for end users to test, because basically, since everything's going in an independent fashion, it's hard to keep track of, well, I'm testing exactly this version of this list of microservices. So that you might get increased throughput, but that's harder. These services become more disposable. Yes, they do. Certainly more than a traditional architectures, but you have to be very rigorous in contract testing. If you're going to replace a service, the new service better do exactly what the old service does, or you're going to have trouble. All right, further reading. Basically, I'll just point out the first one. Matt Stein maintains a reading list on microservice articles, and he keeps it up to date. It's a good place to go if you want additional information. And there has to be questions. If not, we can go get there.
So for a browser, when you backend for frontend files of different microservices, do we wait for all of those to complete and then display everything?
Yes, yes. The idea is that's basically that web backend is basically the consolidator. So it'll have one call coming in that'll break out into X number of microservice calls, either directly or indirectly, and it'll gather the data needed for the response and return it as when needed. Yes, sir.
Yeah.
I'm sorry.
So I read somewhere that it is, I think even depending on who you talk to, some people compare this to like a fine-grained SOA. Is that really what it is?
It depends on your definition of SOA. To me, it really doesn't. Microservices are more coarse-grained than fine-grained. Having said that, what's coarse and what's fine, right? Those are relative terms. It is similar to SOA in that it's service call based, but I mean when I think of SOA in most organizations, I think of mule flows, camel flows. I think of transformations for messages from point A to point B, and microservices don't do that. All right, so I guess I'd have to, if somebody put a gun to my head, I'd have to answer kind of, sort of, maybe, but not really. Okay, yes, sir?
With all the fine print and all the caveats about that. Say we have a monolith right now, and it has its own problems. Some of, not all of the problems you mentioned at the beginning. It feels like a lose-lose. I mean, if I stay with the monolith, I have its problems. If I switch to microservices, I have those problems. Why switching and why?
Well, keep in mind, microservices isn't all or nothing, right? You can take a monolith and say, hey, I've got this bucket of complexity that I want to factor out. And basically then you have something that's a little less of a monolith relying on a microservice.
So start chipping off from.
Right. It doesn't have to be all or nothing. You can make educated design decisions on what you want to factor out. All right. And in fact, if you're just getting into microservices, that's kind of how you want to start out, right? Because you'd really want to learn all your rookie mistakes on something that's preferably not mission critical and something that's important enough to be noticed, but not important enough to be, basically you cut your teeth on a couple up front, and then you expand scope from there. If you got success. Other questions?
So you mentioned Mule. Where would you see something like Wizard